In this video, we're going to continue on with our cloth demonstration as Lee shows us how we can construct a soft body object.
Right. When we started talking about physics and talking about rigid bodies, we said that rigid bodies are non-deforming.
Mm-hmm.
This is a way that we can kind of cheat that. So let's get started. What we're going to do is I'm going to position our camera back a little bit closer to our world origin. And we need to create another game object. So we're going to create an empty game object. And I'm going to name this one beach ball.
Okay.
It's not really going to be a beach ball because I don't have beach ball texture, but I'll cheat. So we've got our beach ball. And we need to make a cloth out of it. So
All right.
we'll go to physics. We're going to go to cloth render. That way we get an interactive cloth along with it.
Mm-hmm.
And for our mesh, we're going to select our sub-div sphere. So we've got that selected, and here we've got our sphere. Now, to give it a material, let's see, wrong one. I have in here somewhere a material that's a checkerboard. So now I just got to figure out what happened to the beach ball. Oh, somehow I messed it up. All right. I can fix this. All right, so now we have our pink. We need to get rid of that. That's driving me crazy. So,
Yeah, we do.
So let's see if I can find one of our box textures. Yeah, something like that. Now if I drag that on there, yeah, that's even worse. There's one of them in here somewhere. There we go. That'll work a little bit better. Not perfect. But, so now we've got a checkerboard on our beach ball.
Okay.
Now, I can put this over here, and let's go ahead and hit play, see what happens.
Sure.
All right.
And it looks like it just falls and splats into the ground.
Yeah, that's not very attractive.
Kind of crumples in on itself.
Yeah, that's not like a real beach ball.
Yeah. That's
Well, it is if you don't inflate it.
Sure, sure.
So let's go ahead and split this over here for now so it doesn't keep jumping back and forth. Move the camera. So we need to inflate our beach ball.
Mm-hmm.
Now the funny thing is, putting air into a beach ball means we need to put pressure in it. That's what holds it up.
Right.
Conveniently enough, we happen to have a setting called pressure. So pressure is going to dictate how stiff our beach ball is.
Okay.
So we can go ahead and, let's try 0.5, see what we get. So if we go ahead and hit play.
Oh, it feels like it's got a little bit of air in it.
It's got a little bit, not much.
Mm-hmm.
So let's go ahead and pause it. Go back to the beach ball. Let's try it with 1.5. So we'll go ahead and hit play again. Now it's got a little bit more air.
Wow. That's impressive.
So it's starting to feel like a beach ball. Still a little underinflated.
It's like a big underinflated rubber ball.
So let's go back to our beach ball. So what if we do 10?
In fact, this is probably going to end up being a bit more like a rubber ball, because in the end, beach balls don't really deform that much.
So let's try 10.
Boom, boom, boom. It needs a sound effect. It really
Right.
does.
But notice what's going on with the shape. It's kind of getting blown up and deformed.
Yeah,
We've
it's
over-pressurized it.
It's pushing outward a little bit. It's kind of interesting.
So, again, we just a little bit more trial and error trying to get the right number. I think about 3 should do it. Let's see what we get. So about 3.
Okay. Yeah, it's not really like a beach ball. It's just kind of like a big, heavy, mostly inflated rubber ball, but it does show off the soft body behavior really nicely.
So, now, if we select this, we can have some fun with it, and let's drop something on it.
Okay.
Because I want to show off something else. So if I pause, or not pause, but stop playing, let's create another game object. This time I'm just going to create a cube. I'm going to take this cube, and let's zero out its X and Z. Let's make sure our spheres X and Z are zeroed out, because I want this to kind of land right on top of it.
Mm-hmm.
So let's space this out and see what happens. So if we start off,
Well, not much yet.
yeah, not much. There's something I forgot. We need a rigid body.
You didn't hit play yet, so you didn't forget.
Yeah. So let's hit play and see what happens. So
Ooh, it just squashes it flat, and then it squeezes out from under it. That's awesome.
So there's not a lot of force that is being imparted back on the object it collides with.
Mm-hmm.
Now, you would think if you drop something heavy onto a rubber ball or an inflated ball that there would be some bounce back on the object.
Sure.
To accomplish that, we have another setting called collision response.
Okay.
Now, this is how much force to apply back to the object during a collision. Now, we can dial in different numbers until we get the effect we want. I'm going to start with 1 and see what happens.
Okay.
So, if I come over here and click, and we watch.
Ooh. It's almost bounced off it like it was really hard.
So now we get some force coming back out of it. So, and this is how you can achieve effects like trampolines, or, you know, if it was a giant rubber wall
that you want to just jump into,
right,
or throw something into.
And you can get really crazy and dial stuff up. Let's try 5 and see what
Oh
happens.
no. Yeah, you're just going to send that box flying.
All right. So probably not too believable. But it does get the point across that you can impart energy during a collision.
Absolutely.
So let's go back down to, let's say, about 0.75. Nothing too terribly crazy, but enough to be a little fun.
Nice.
All right, so let's do a little review real quick. Now, we've mentioned bending stiffness and stretch stiffness. This also applies with this. If we want to take the bending stiffness and crank this up, we can try it again. And as you can see, the ball doesn't bend nearly as much as it did before.
Yeah.
So that's how we can stiffen up the sides of the ball.
Gotcha.
Now, stretching stiffness, again, that's going to be how much the vertices are allowed to stretch. Dampening is or bleeding off energy over time. The thickness of the material, we can adjust that. We can determine whether or not to use gravity or not. Self-collisions, while it works great in a flag example, not quite so useful in this one, so we don't need to worry about it.
Sure.
Which means it saves us a lot of processing power. So if you don't need it, don't use it. We're not going to blow the ball around, so we're not going to mess with acceleration. But if you wanted to,
you could.
Yep. External acceleration is a constant, and random is a fluctuating turbulence.
Is the external acceleration going to be applied locally or globally?
This one is a global.
Okay.
So, and mesh is the mesh that we're using for our material. Friction and density, now we can dial these up because we're interacting with the ground some. So we could dial this up to, let's say, 1. Take our density if we wanted our ball to behave like it's a little bit heavier.
Oh, wow, yeah.
So now we have a much heavier ball, and it imports quite a bit of energy to it.
Yeah, it does.
And you notice, even if I dial this back down to 1 with a friction of 1, our ball doesn't roll around a whole lot. It just kind of bounces and stops.
That's true.
So that's what the friction setting does for you. It will, you know, kind of slow down the ball quickly. So if you've got a ball and it hits and it just rolls away, use friction to get it back under control.
Right.
Pressure, we've covered. That's how much inflation that ball is going to get. If the number goes too high, it starts to deform the ball. Too low, it kind of collapses in on of it.
Gotcha. It's like it's taking those original vertices and trying to pull them back to their original positions.
Right. And then collision response is how much energy is it going to part into an object that it collides with.
Okay.
So those were the settings that I wanted to cover in this video.
Which this only seems to leave, what, attachment tear, attachment response. Oh, or did we already talk about attachment response?
No, we're not really gonna demonstrate it. I'm gonna talk about what it does.
Okay.
But we're really not going to demonstrate it because I don't have a mesh that would make that easily
no
visible.
problem.
But we will talk about what it is. I can show you what attachment tear factor does. I'm going to show you tear factor.
Okay.
So as you can imagine, that means we're going to put a cloth together that's terrible.
That's awesome.
So not terrible as in terrible cloth, but terrible.
Can be torn.
There you go.
There you go.
All right, so that's it for this video, and we'll see you in the next one.